In this video, we're just going to do some review on some topics that we've been talking about. So, first of all, finding the interval of convergence. Remember, interval of convergence, we do the ratio test. So 3a. We go straight to multiplying by the reciprocal. Taking the limit as n approaches infinity. So we do some simplifying, or we take this and pull it out front. I'm doing this pretty quickly. If you need some more review, you might want to look back at a earlier video. So I'm just kind of doing the real quick breakdown of this. Remember, the whole point of ratio tests, we're trying to be less than 1. Okay? This limit is 1, so we end up with just 3x minus 2 has to be less than 1, but it also has to be greater than negative 1. Remember, we need to account for the for alternating series. So we add 2 to both sides, so we have 3x. Yeah, divide that. Now, at this point, we should plug these back in to the original. So if I do that, 3 times 1 minus 2, 1 to the nth over n. So maybe I'll make a note here. If I plug in 1, x equals 1, I get the series 1 over n, and that diverges. If I plug in this 1/3, let's do that. 3 times 1/3 is 1, minus 2 is negative 1. I get negative 1 to the n over n. Well, that converges conditionally. So I go back and I say that it could be equal to 1/3. Okay? Next. Set up my ratio test. Yank this out front. Simplify that. Must be less than 1. Now, n plus 1, the limit as n goes to infinity, this is infinity. So I end up with x minus 4 multiplied by infinity has to be less than 1. Well, there's only one thing that will work, and that's to make this thing in parentheses 0. So 0 times infinity was the only thing. So x would be 4. So there's no real interval of convergence here. It's just one value that would work, and that's it. Okay, let's do the last one. Oops. The reciprocal. Yeah. Now, this up here would be 2n plus 3. So I have 2 extra x's on top. So when I do my simplifying, this will go and this will go, but I still have x squared that I would pull up front. So I'd have x squared times the limit as n approaches infinity of 1 over n plus 1. And remember, I need this to be less than 1. Well, this limit is 0. So x squared times 0 has to be less than 1. Well, what will work? Anything. X could be anything and would work. So from negative infinity to infinity. let's look at a couple more things. Which of the following is the sum? So I would start right away, recognize it's geometric. It's the only one we really know how to do the sum of. We have pi over e squared to the n. And notice, e to the 2 to the n, that's e to the 2n. Okay. So my first, we're starting at 0, so n equals 0. So the first term in my sum, anything to the 0 is 1. And the ratio is pi over e squared. So if I got a common denominator on the bottom, and multiply this by e squared over e squared, I'd have 1 over e squared minus pi over e squared. Well, dividing by a fraction, you flip, so we should have e squared over e squared minus pi. It's d. Okay. Next, assume that f has derivatives of all orders and gives us a set of derivatives and says what is the Taylor polynomial. Well, Taylor, remember, is the nth derivative evaluated at, for us, I guess, 0, since that's what we're about here, over n factorial, and then x minus, in our case, 0 to the nth power. So the very first term should be 2. They say that the derivative is 2, so I'd have 2 over 0 factorial times x to the 0. Next would be 1, negative 1, I guess, over 1 factorial times x to the first. And again, we just use the number derivative. So the second derivative goes with x squared, the third derivative goes with x cubed, and so on. Everything has to agree. So this next one we've got is 6. That's the second derivative, so we put over 2 factorial, and we have x squared. Then we have 12, that's the third derivative, so it goes over 3 factorial and x cubed. And now we just reduce. 6 divided by 2 factorial is 3. 12 divided by 3 factorial is 2. So we should have a 2 minus x plus 3x squared plus 2x cubed. Looks like A.